Okay, so in 2.1, the title of this section is What is a Function? And by the end of today, you're going to be able to find the domains of functions and evaluate functions given values and expressions. The first thing we're going to talk about are piecewise defined functions, which you did a little bit of in your preview packet. So those are defined by different functions on different parts of the domain. Okay, and we've been dealing with the domain. We know that that's going to be the possible input values or the x values on the graph. Okay, and in example 1, we are just going to do the evaluation. So if you are evaluating, okay, if you have a piecewise function, okay, it's if x is less than or equal to 3, if x is greater than 3. So we have to find these three things, f of 1, f of 3, f of 5. So you just have to find which one of the inputs it's going to go into. So if x is equal to 1, it's going to fall into the x is less than or equal to 3. Okay, so for f of 1, you're going to use the first equation. So instead of 3 minus x, we have 3 minus 1. So we would just say f of 1 is equal to 2. Okay, so the equation you use is based on whether it's less than or equal to 3 or greater than 3. Okay, so which one would 3 fall into, the first one or the second one? Yep, so f of 3, again, we're going to use 3 minus x, which is 3 minus 3, so f of 3 would be equal to 0. Okay, and then for 5 is greater than 3, so f of 5, instead of x squared, we plug in 5, so f of 5 is 25. Okay, so you guys did this in your preview packet, and it's okay if you don't use every equation. One equation you might use multiple times, like we did here. One equation you might not use at all, so that's okay. All right, and then this says, what if there was no x in the expression and you just had a constant term? So if you just had a number, then how would you evaluate? Let's look at an example to help us explain this. So if you had something like 10, if x was less than or equal to 3, or 2, if x was greater than 3. Okay, and then we're going to show what this graph would look like. So we're going to draw a rough sketch of the graph. Okay, and our key value here is 3. All right, so if it was 10, if x was less than or equal to 3, we'll just make this our 10. Okay, so you would have a closed circle. And then if it's just a constant, it's just a horizontal line, right? Going to the left. And then if it's at 2, I would say this would be 5, so maybe 2 would be here. And then we'd have an open circle going to the right. So no matter what you plugged in, if it was less than 3, you would always end up at what y value? 10. And if it was greater than 3, what y value would you end up at? 2. Okay, so your solution will always be the constant. Okay, so if there's no x term, your solution is just always going to be that number. Okay, so then for example 2, we are going to use the function to evaluate the indicated expression and simplify. Okay, and you guys don't know this yet, so this is going to seem kind of strange. This is actually going to tie back in to our preview of calculus at the end of the year. So there is a reason why we're doing this f of a plus h, even though that seems unfamiliar right now. So just like we did above, when you had f of 1, you plugged in 1. When you had f of 3, you plugged in 3. So if you're evaluating f of a plus h, that means you are going to substitute a plus h for x. Okay, so we're going to be substituting an expression. Okay, so they give you f of x, so now what we're going to do is f of a plus h. So one strategy I use to help me is instead of the x's, what I do is I put parentheses and I write everything out first. So it's 3x squared plus 4 times x minus 1. So I write this exact expression except without my x term because that's where I'm going to plug in my a plus h. Now, when you simplify, you have to use your order of operations. Okay, so you have to simplify what's in parentheses if you can. You can't because we can't add a plus h. Then you go to the exponent before you multiply and divide. So if you have a plus h squared, remember, it's a plus h times a plus h. Okay, and then here you can distribute. 4 times a, 4 times h is 4a plus 4h minus 1. And then with the a plus h times the a plus h, you have to FOIL. Okay, will you guys take a second and FOIL that? Okay, so you're going to do the first times first. So a times a is a squared. Anytime you're multiplying the same thing, the middle doubles. So AH and AH is 2AH, and then H squared. Okay, and then you are going to distribute from there. Okay, so there you used FOIL. So you'll have 3a squared plus 6ah plus 3h squared. Okay, and then we still just have to bring these down, plus 4a plus 4h minus 1. I just didn't write those again. All right, and then let's look for any like terms. So like terms have to be the same variable to the same power. So there's no other a squareds, there's no other ah's, h squared, ah, and then 1. So I don't have any like terms. So this is just your final answer, is this whole expression. Okay, now if we look at part B, we have an f of x again, we have a polynomial, a quadratic, and then it says to evaluate, and this is getting more complicated. So notice these first two parts are the same, but then it's minus f of a divided by h. Okay, so when you're doing this, I have found that sometimes it's easier to do the f of a plus h and then subtract the f of a. So I'm fine if you want to do that in 2 steps instead of writing everything out a bunch of times. That is perfectly fine. So I'm going to give you a second to simplify the f of a plus h for this equation. So again, if you want, you can use the same strategy I started with. Okay, so the f of a plus h. All right, and then let's go ahead and simplify that. All right, so let's check and see what we got here. You guys should have the 2a squared plus 4ah plus 2h squared plus 4a plus 4h minus 1. Okay, what questions do you guys have on that first step there? Okay, so now we're going to put it into this fraction, okay? So this is going to be equal to 2a squared plus 4ah plus 2h squared plus 4a plus 4h minus 1. And then it's a minus f of a. I'm going to have to squeeze that in there. Okay, so the f of a is just this exact expression, except instead of x, you have a. Okay, now I like to put it in parentheses because if you have a minus, what are we going to have to do? Yep. And then it's all over h. Yes, thanks. Yep, so you have the 2a squared plus 4a minus 1. I must have been saying x at the time. I was writing it. So you replace all of the x's with your a's. Okay, and then we are going to end up combining like terms here. Okay. And when you're doing this on your own, if you can remember to do the distribution, it would be minus 2a squared minus 4a, and then minus a negative is going to end up being plus 1. Okay, so now we're just going to clean it up. So we're going to combine our like terms. So if you have 2a squared minus 2a squared, those are going to cancel out. Okay, 4ah, do I have any other ah's to combine that with? Nope, so I'm just going to write 4ah. Okay, the 2h squared, do I have anything to combine that with? Okay, I don't. And then what about the 4a? Yeah, you have the 4a and the minus 4a, so those are going to cancel. The 4h, nothing to combine that with, so I'm going to put plus 4h. And then you have a negative 1 and a plus 1. Negative 1 plus 1, those are going to cancel. Okay, so it's all going to be over h. Okay, so then at this point, you might notice there's an h in every single one of these. And so what we're going to do is we are going to factor out the h. So we have 4a plus, if we factor an h out, you would just have 2h. We factor an h out here, you'd have plus 4 over h. And the reason why you want to factor that is so you can cancel these out. And then you can write your final answer as 4a plus 2h plus 4. Okay, you don't have to leave that in factored form, so you don't have to take out the GCF. 4a plus 2h plus 4. All right, and then let's flip it to the back. Okay, so this one says if f of x is equal to x plus 4, evaluate f of x plus 2, and then f of x plus f of negative 2. Okay, so let's do the f of x plus 2. Do you guys feel like you could do that without me? Plugging it in. So you have your f of x. Okay, so instead of x plus 4, it's just x plus 2 plus 4. Now, if there's nothing in front to multiply, your parentheses really just go away. This is the same thing as x plus 2 plus 4. So if you combine your like terms, you'll just get x plus 6. Okay, now for this one, you have the f of x plus f of negative 2. So your f of x is just x plus 4, and then it's plus the f of negative 2. Instead of x, you're going to replace it with negative 2. So negative 2 plus 4 instead of x plus 4. And then you just need to combine your like terms. Okay, so 4 minus 2 is 2. 2 plus 4 is 6. And so in this case, they are equal. That does not always happen, where you'll get two that are going to give you the same output. All right, and then we're going to review domains. So we're going to find the domain of the function, and then we're going to write this in interval notation. Okay, so when you are dealing with the domain, okay, there's always two things we look for. Can you guys tell me what one of the things you have to watch out for is with the domain? Yes, so fractions, and the reason why is because when you have a fraction, what can't happen? Yep. So in the fractions, the denominator cannot be equal to 0. That's why we have to watch out for it, because that's when you have limits to what can be plugged in. You can't divide by 0. Okay, so that's an issue. And then what's the other one? Yep, and in particular, what types? We can't have a negative under what type? Even, yep, okay, so with radicals, okay, it's even, I'm going to say even roots. Okay, I'll do this again. Okay, so whenever you have that, you take the radicand and you set it greater than or equal to 0. Okay, so you can't take an even root of a negative. Okay, can you take an odd root of a negative? Yep, so guess what? Whenever you have an odd root, what's your domain? All real numbers. Okay, so some of you might want to go back and check that on your preview packet, because there was one where you had an odd root, and it's just going to be all real numbers. Okay, the other thing we talked about is when you have both. Do you guys remember what it is if you have both? Yes, so if you do have a both situation, which you can see you have right there, you have both, and the radicand is just greater than 0. Because it can't be equal to. All right, so with part A, you're just going to ask yourself, do I have a fraction? Do I have an even root? In this case, I have a fraction, so we know that this can't equal 0. So we have to find the values that do make it 0. So we are going to factor. We want to set this equal to 0 and solve. And when you factor, remember, rules of factoring, always want to see what they have in common. Okay, so what do these two have in common? An x, when you factor it out, you're dividing. X squared divided by x is x. What's x divided by x? 1. Okay, so then they're going to be 2. Yep, so yeah. Okay, so there are 2 stipulations. We are writing this in interval notation. So in interval notation, can you write that x can't be 0 or -1? One thing you can use to help you is the number line. What do you think? Why? Why? Well, think about what they mean, right? Okay, so if it's a hard bracket, if it's a hard bracket, then it means it can be equal to that. Can this be equal to 0? Okay, so do you want it to include 0? No. So if you don't want it to be included, it has to be what type of bracket? Yep. Okay, so what this does is it breaks the lineup into 3 pieces. This is the first piece, the second piece, the third piece. What do you connect the pieces with in interval notation? A union. Great. Okay, so this first piece goes from -infinity to -1. Okay, you don't want to include it, so it's a soft bracket. And then you need the union, -1 to 0, union, 0 to infinity. Okay, for B, you have an even root. Okay, so if it's an even root, we said we have to take whatever is underneath and set it greater than or equal to 0. Okay, and then we are going to factor this. This is a nonlinear inequality. This is exactly what we did in 1.7. Okay, and I gave you a hint on your packet for this on Friday that you had to do your table. Okay, anytime it's a nonlinear inequality, you've got to do your table. Okay, so we're going to factor, and this is a special pattern. You guys remember what the pattern's called? Yeah, great. So 4 minus x, 4 plus x. So start with the square root of the first one, square root of the second one, greater than or equal to 0. Okay, so for the nonlinear inequalities, you are coming up with your key values. Your key values are just going to make this 0. So in this case, your key values are, what would make this factor 0? 4. And what would make this factor 0? -4. Okay, so when you're doing your table, remember how I said you can do this with your number line? So you have -4 and then 4, and then you can write your intervals. So it's either -infinity to -4, okay, and then this is equal to. So if it's equal to, what type of brackets do I have? Yep. Great. So you should have hard brackets with the 4 and the negative 4. Soft bracket with your infinity always. And then we're just going to pick our test points. Okay, so you have the 4 minus x and the 4 plus x. Those are your factors, and then we'll decide if they're positive or negative. Okay, so what would be a good test value for this one? -5. What's 4 minus -5? A positive 9. Yep. And then 4 plus -5? A negative, so positive times a negative is a negative. Okay, for this one I would choose 0. 4 minus 0 is 4, that's positive. 4 plus 0 is 4, that's positive. Okay, and then we can do 5 again. 4 minus 5, negative. 4 plus 5, positive. Okay, now remember, which one you want is dependent on what you have. So this is greater than or equal to 0. Okay, so you're going to be looking for the positive interval. And because you're doing the domain, you should always be looking for the positive interval, because in this situation, you're always going to want it to be positive. Okay, so this is what we want. So then your solution is going to be -4, 2, 4. No, you don't have to. I like doing it for this so you can see there's going to be 3 different pieces. For this one, you already have your intervals in the pieces, and then you will choose the positive. Okay, so based on what we talked about here, can you guys set up your inequality? And then you can solve that inequality. Is it a nonlinear inequality or is it linear? It's linear. So if it's linear, you can just solve it like an equation. You would just have to watch out if you had a multiplier divide by a negative. Okay, so when you're doing the domain, you just have to make sure this radicand is greater than 0 because it's both. So you just have to set that greater than 0. So to solve, subtract 2 from both sides. Again, it's linear, so we don't have to do a table. Okay, all we have to do is write this in interval notation. Okay, and many of you can do this without setting up the number line. If you're a more visual person and it's helpful for you to see, just drawing it for that purpose. X is greater than -2. So if it's greater than, it's an open circle, which means you have what kind of bracket? Yep. And then this is where you can see, okay, -2 is the lowest value, infinity is the highest value. It would go in the other way, which it wouldn't for this. You would start with negative infinity. Okay, good. All right, what questions do you guys have for me in finding the domain? All right, let's talk story problems.
I have a question on the.
Oh yeah, yep.
Couldn't you just like where root the radical integral answer?
So you actually can't do that because of the minus there. If they were multiplied together, then you could simplify that. But remember, for these, we're not trying to solve for x, we're trying to find the domain. So we're trying to figure out what the possible values are, right? Which is why I don't even take the square root here, because I'm not trying to undo the square root. I'm just trying to find out what values for x are going to make this true. So in that case, we're using these rules to help us find what the possibilities are. Okay, and then for example 4, we're talking about the cost in dollars. So the cost C in dollars of producing X yards of a certain fabric. And they give you an equation, C of X, that represents that cost. So the first thing it says is find C of 10 and C of 100. And apparently I made people do this without a calculator. So let's do the C of 10 together. Let's see how it goes. Okay, so for C of 10, you have the 1500 plus 3 times 10 plus 0.02, 10 squared plus 0.001, 10 cubed. And I really believe in my heart of hearts I wouldn't make you do anything this complicated on your test. But this is 10, so let's just remind ourselves of some rules we already know. Okay, so you have 1500, 3 times 10 is 30. Okay, when you square 10, what do you get? Yes. So let's just think about this. When you multiply something by 100, what does that do to the decimal? Yeah, so if you did that, just move it 1, 2, what would this number become? 2. Okay, so this is just going to be plus 2. Okay, and then something similar is going to happen here where you have 10 to the third. What's that? 1,000. Okay, because if it's 3, you have 3 zeros. So you're just going to move it 3 places. 1, 2, 3. So that's just going to be plus 0.1. Okay, so we're just going to add 1500, 30, 2, and 0.1. So 15, 32.1. What would that be in money? Yep. So $1,532.10. Okay, and then let's try this with C of 100 over here. See, that wasn't as bad as we thought it was going to be, right? I said, right? I know we're in our jammies today. I think every pajama day we should have a nap hour, right?
Yeah, it should be 4 hours.
I was thinking more 6 hours. Just be relaxed before we go home.
Yeah, 6 hours.
I know. Let's be nice.
How was the meet? How was the meet?
All right, so let's do which ones of these we can do, okay? So we can do 3 times 100. Okay, if you square 100, do you guys know what that does to the zeros? So remember when we had a 10, it was the number of zeros. This time it's just going to be double it. So if you have 100, it's going to be 100, 0, 0. So 10,000. Okay, so if you have 3, Yeah, so instead of 3 zeros, you're going to have how many? Yep, so 2 produces 4, 3 is going to produce 6. $1 million.
How much more do you have in mind?
Dreams. So every time you have a 0, that's just going to represent how many places you move it over. So 10 is 1 place, this is 2, this is 3, this is 4. So we're just going to move it 4 places here. And then, so 10 is 1 place, 2, 3, 4, 5, 6. Okay, so 1, 2, 3, 4, this would be 200. 1, 2, 3, 4, 5, 6. 100. So we just have to add 1,500, 300, 200, 100. So you can tell pretty easily this is 2,000. So 2,100, 2,100. That's not too bad, right? All right, so now we're going to talk about what the answers represent. So when you have to do this on an assessment, I'm going to be looking for specific units. So I always think of the inputs and the output to make sure that you have both of them. Okay, so C of 10 represents that it costs $1,532.10 to produce, and then
10 yards of paper.
yeah, great. Okay, so notice that you have the cost, the units, okay, that's your output, and then the input is the 10, and then you have your yards of fabric. Okay, so those are the key things that I'm going to be looking for. Do you guys think you could do it with the second one? Mm-hmm. Is somebody there or no?
So if something bad ever happens,
Yeah,
I'm going head straight to that window. Huh?
we can open it.
Well, what if we don't have time? Like just saying. Shoulder.
Go practice it with the next door. All right, let's find C of 0. What does this represent?
0.
Yeah, what is C of 0? Yeah, that's what I mean. Okay, yeah, so yeah, it's the initial. So if find C of 0, we know C of 0 when you plug that in, right? These all become 0. You have 1,500. No, but what does it represent? Yeah, so it's your startup cost of doing the manufacturing, right? So maybe you have to rent the building. Maybe you have to
Down payment for you as this not to get through there.
buy the machinery. I agree.
Okay.
So this represents, you can say the startup cost. It's if we say it in unison.
Yeah.
Brennan, who did your grades, man? Okay? You gotta be smart about this. All right, and then what if X represented the yards measured in hundreds? So this is something that you're going to have to pay attention to. Sometimes, in order to make an equation simpler, we determine the units. So if X is represented in hundreds, okay, we're going to talk about what our answers in part A would represent. It's only the X that's being changed in this case. Okay, so for C of 10, I'm going to give you the sentence structure. So the output does not change. The output is not measured in hundreds, so it's going to cost the same amount to produce blank yards of fabric.
It will be said in part A.
Yeah, they're both in part A. Okay, so the only thing that's going to change is going to be our X value. So if our X value is 10, but that's measured in hundreds, what can I do to 10 to find out how many yards this is going to be? Multiply 10 by? Yep. Okay, and when you multiply 10 by 100, it's like the 1 times the 1, and then you have your 3 zeros. So it would produce 1,000 yards of fabric. Okay, and then for this one, if it's 100, again, because it's measured in hundreds, you multiply by 100. What's 100 times 100? 1,000. Okay.